And welcome back to 2.4, where we're dealing with chemical changes and chemical reactions. And in this last podcast of this particular chapter, we want to talk about the conservation of mass. During any chemical reaction, the mass of the products, which is what you're ending with, that's a T there, this is what you end with. Whatever you end with, the mass of that is always equal to the mass of the reactants. Now the reactants are what you start with. So basically, what happens is, whatever you start with, reactants, going to products, the mass of this, whatever this weighs, has to be the same as this. And what we say is that matter is neither created nor destroyed, it only changes forms. That is the law of conservation of mass, something that you may have even learned about in middle school. It's one of the early laws that we discovered. Well, what do we mean by mass being conserved? What does this look like during a chemical reaction? Well, let's look at a few examples here. So let's scroll down. So here's example number 1. It says hydrogen and oxygen react chemically to form water. How much water would form if 4.8 grams of hydrogen reacted with 38.4 grams of oxygen? So let's go ahead and write this out. I'm just going to use words for right now, but eventually we're going to turn these into symbols. But if you take hydrogen and oxygen, should be Y there, hydrogen and oxygen, and you put them together, you're going to form water, H2O. If you have 4.8 grams of hydrogen and 38.4 grams of oxygen, the total mass of your reactants has to equal the total mass of your products. In this case, if you add these two up, 38.4 and 4.8, that's going to be, what, 43.2? grams total of reactants. So that means the mass of your product must also be 43.2 grams because the mass is conserved. Now in this case there's only one product, so that means all of it has to be water. So if you start off with 43.2 grams of reactants, hydrogen and oxygen total, you're going to end with 43.2 grams of water. Try another example. I might illustrate this. Scroll down. Scroll isn't working. There we go. Okay. Example number 2. When ammonium nitrate explodes, the products are nitrogen, oxygen, and water. Alright, so let's go ahead and write this out. We have ammonium nitrate. That's all you're starting with. And what's going to happen is it's going to explode, and it's going to form nitrogen, oxygen, and water. Water vapor, actually. Now the question goes on and says, when 40 grams of ammonium nitrate explodes, 14 grams of nitrogen and 8 grams of oxygen form. How many grams of water will form? So let's go ahead and take a look at this. We have 40 grams of ammonium nitrate to start with. We're going to form 14 grams of nitrogen and 8 grams of oxygen. It's always good to draw things up as a picture, and these ways of writing these equations work out really nice. So total on the reactant side, the only thing that we started with was ammonium nitrate. And you had 40 grams total of the ammonium nitrate, and that's your only reactant. So that means you're going to have to end with a grand total of 40 grams of product. So 40 grams total of product are going to be formed. 14 of it's going to be nitrogen and 8 of it's going to be oxygen. So if we subtract the 14 and the 8, scroll down here. If you subtract the 14 and the 8 grams from our original 40, well, 14 and 8 is 22, so subtract that from 40, you're going to get 18 grams left over. So that means that 18 grams of water must be formed. That's the law of conservation of mass, and that concludes Chapter 2.